Okay, so today you're going to be watching a video on solving systems of equations. So today we're going to be solving systems of linear equations. So we're going to be given two separate equations, and we're going to be asked to solve for x and y. Now, when you do this, you're going to be finding the x value and the y value. You're going to be solving for it algebraically. Now, these x and y values that you're finding is the x and y value that make both equations true all at the same time. So the reason we set these up the way we do is so that when we solve for x and y, when we plug it back in, it'll work for both equations. It'll make both equations true. So we're going to be given the system, and then we will solve for x and y. Now, understand there are multiple ways of solving systems of equations. Today we're going to be solving them by substitution. Now, here are the steps to solving by substitution. The first thing you're going to do is isolate a variable. So you're going to look in one of the equations or look in the other equation, and you're going to get one of the variables all by themselves. Now, you can do that by using the correct operation to get from one side of the equation to the other. I always choose the easiest variable to get by itself where I don't have to deal with fractions. Your second step is to substitute whatever you solved for by putting it back into the other equation where the variable is. Then your third step, you will combine like terms and solve. Fourth, once you've solved for one of the variables, you'll plug the answer of that variable back into one of the equations, one of the original equations. You'll plug it back in to find the other value. Now, you're probably not going to have time to write all this down before I just start by my examples, but I really think that if you don't necessarily need these steps, but if you watch my examples, you'll understand what we're doing and the process will speak loud enough. So if you don't have time to write down these steps, pay close attention to the examples and how I do it, and I'll be showing you these steps. So here's our first example. All right, so it asks us to solve the systems of linear equations. Now, in our first equation, we're given x plus 3y is equal to 1. And in our second equation, we're given negative 3x minus 3y is equal to negative 15. Now, remember, we're trying to solve for x and y, where we will solve for x and y, and whatever we find as our answer will work in both equations. Now, today we're learning how to solve these by substitution. So if you think back to our steps, the first step was to isolate a variable in one of the equations. So looking at these two equations, I'm going to isolate a variable. Now notice, if you look right here, x can easily be got all by itself. I'm going to get x all by itself. So in this top equation, I'm going to get x by itself by subtracting 3y from both sides of the equation. So then I have my new equation here. X is equal to negative 3y plus 1. I just got one of the variables all by themselves in my top equation. Now once you've done that, you're going to take what you've got and you're going to substitute it into the other equation wherever there's that variable. Now notice, in this problem, I solved for x. So I'm going to take that and substitute it into the other equation wherever there's an x. So I'm going to write down what I have. Negative 3 times x. Now remember, we're substituting in negative 3y plus 1 into the other equation wherever there's an x. So I'm actually going to have negative 3 times negative 3y plus 1. And then we still have this here, minus 3y is equal to negative 15. I just substituted that in. And now we'll go through and we will distribute and then solve for our variable. So looking at this, I have negative 3 times all that stuff. So I need to distribute it in. Negative 3 times negative 3y is positive 9y. Then I have negative 3 times positive 1, which is negative 3. And then I still have my minus 3y from right there, which is equal to negative 15. Now I'm going to combine all like terms. So I have 9y's minus 3y's, and that gives me positive 6y's. So I have 6y minus 3 is equal to negative 15. Now remember our goal. We're trying to solve for the variable. We're trying to get y all by itself. So I'm going to go ahead and add 3 to both sides of the equation. And that will give me, over here on the left, I still have a 6y. Those add up to be 0, which was the point, is equal to, and then I have negative 15 plus 3, which will be negative 12. Now from there, I'm trying to get y alone, so I'll divide both sides by 6. So I get y is equal to negative 2. Negative 12 divided by 6 is negative 2. I solved for y. Now I need to solve for x. This part's the easiest part. Let's solve for x by taking that y value and plugging it back into one of the original equations. So I'm going to take y is equal to negative 2, and I'm going to substitute it back in up here, in for y. Now, I have x is equal to, I'm substituting in negative 2 wherever there's a y, so right there. So I'm going to have x is equal to negative 3 times negative 2, and then I have plus 1. Just substituting it in, the y right there. All right, if I go ahead and calculate this, I have x is equal to negative 3 times negative 2 is positive 6 plus 1, so we get x is equal to 7. So we found x and we found y. So here are my two answers. X is equal to 7 and y is equal to negative 2. Now they like us to write our answers as an xy point. So I'm going to write my answer right up here in this corner. My final answer is x comma y. We just found x. X was 7 and y was negative 2. So this is how I would write my final answer. 7 comma negative 2. All right, let's do another one. Solving the systems of linear equations. Here we go. So we have negative 3x minus 8y is equal to 20. That's our first equation. And our second equation is y is equal to 5x plus 19. Now notice this. Our first step is to get a variable all by itself. Well, notice right here, our y is already all by itself. So now we can take that. We don't even have to solve for a variable. It's already isolated. So we can take that y and substitute it into the other equation wherever there's a y. Since we were given y is equal to this, we'll substitute that piece in wherever there's a y into the other equation. So that's going to give me, on top, I'm going to have negative 3x's still. Then I have minus 8 times y. But remember, instead of y, we're substituting in this value. So I'm going to make sure I always use parentheses when substituting. 5x plus 19. And that's equal to 20. I just substituted that in. And now we'll go ahead and simplify this and then combine like terms and solve. I have negative 3x's. And then notice I have negative 8 times all that stuff. So I need to distribute in negative 8. Negative 8 times 5x is negative 40x. Negative 8 times positive 19 is negative 152. And that is equal to 20. Now over here on the left, I'm going to combine all like terms. Negative 3x minus 40x is negative 43x's. And then we have minus 152 is equal to 20. Now remember, our goal is to get x all by itself. We're trying to solve for x. So I'm going to add 152 to both sides of the equation. So over here on the left, we're going to have, and I'm going to come over here so I have more room. Over here on the left, I have negative 43 x's, which is equal to, and then you'll do 152 plus 120, and we get 172. Now solving for x piece by piece, I'll divide both sides by negative 43. So we get x is equal to negative 4. All right. Now we solve for x, so we do need to solve for y. Now we can take that x value and plug it back into the other equation. Now I'm going to go plug it in right over here because then solving for y is really easy. So I'm going to go from here, substitute that x value back in for x, and then find y. So we're going to have y is equal to 5 times x, but x is negative 4. So we'll have 5 times negative 4. Plus 19. So once again, I'm substituting in the x value wherever there's an x. So then if I calculate that, I'm going to have y is equal to 5 times negative 4 is negative 20. So we have negative 20 plus 19. Negative 20 plus 19 is equal to negative 1. So y is equal to negative 1. Now remember, we write our points as x comma y points. So our x value was negative 4, and our y value was negative 1. So that would be our final answer here. Negative 4 comma negative 1. Make sure you're writing them x comma y as well. So our x was negative 4, our y was negative 1. All right, here's another one. So we have 2x plus y is equal to 20. That's our first equation on top, and on bottom, we have 6x minus 5y is equal to 12. Now remember, the first thing we have to do is solve for a variable if it's not already isolated. We need to isolate one of the variables. You can choose either equation, but always choose something that's not going to cause you to have fractions. So if you look on top here, I can solve for y pretty easily. I can get y all by itself. I'm going to subtract 2x from both sides of the equation. And so those will cancel out. So we will have y is equal to, I'm going to write it in standard form. So I'm going to put my negative 2x first. And then I have plus 20. All right. So I just rewrote this top equation as this. And now we can go ahead and make our substitution. So we're going to substitute that value into the other equation wherever there's a y, since this happened to be y. So we're going to substitute it in right there. So now we're going to have 6x minus 5 times y, but y we're substituting in negative 2x plus 20. And then we have right here is equal to 12. So once again, I just substituted into our y that negative 2x plus 20. And now I can solve. So I have 6x. And then notice I have negative 5 times all that stuff. So I'm going to have to distribute negative 5 through to each term. Negative 5 times negative 2x is positive 10x. Negative 5 times positive 20 is negative 100, which is equal to 12. Now over here on the left, I'm going to combine all like terms. 6x plus 10x is 16x's, and I still have minus 100 is equal to 12. And now from here, our goal is to get x all by itself. I'm going to add 100 to both sides. So that leaves me with 16x is equal to 112. Then from here, we're almost finished. Divide both sides by 16. And that gives us x is equal to 112 divided by 16, and we get 7. All right, we solved for x. Now we need to solve for y. So I'm going to go plug that 7 in back up into this equation wherever there's an x so I can find y. So we'll have y is equal to negative 2 times x, but remember x is positive 7, so we're going to put positive 7 and then plus 20. So we'll get y is equal to negative 2 times 7 is negative 14 plus 20. So we're almost there. Y is equal to negative 14 plus 20, which is positive 6. So we have our x and y. We know we write our answers as x comma y. So our final answer would be 7 comma 6. And this would be our final answer. All right, we're going to do number 1 together on the worksheet. So if you'd like to do that, we can do it together. So looking at this one, we're given y is equal to 6x minus 11. And then on bottom, we have negative 2x minus 3y is equal to negative 7. And we're solving by substitution. So our first step is to isolate a variable. But notice, this top equation here already has a variable isolated. So we can go ahead and make our substitution. We're going to substitute that value into the other equation wherever there's a y, because it was a y value. So we're going to have negative 2x minus 3 times y. Y is 6x minus 11, which is equal to negative 7. Now we'll go through and solve. So we have negative 2x, and very carefully, we have negative 3 times all that stuff. So I'm going to distribute negative 3 through. Negative 3 times 6x is negative 18x. Then we have negative 3 times negative 11, not making any sign errors. That's positive 33. And then that is equal to negative 7. Then over here on the left, I'm going to combine any like terms. Negative 2x's minus 18x's is actually negative 20x's. And then we have plus 33, which is equal to negative 7. Now from here, we're trying to get x alone piece by piece. I'm going to subtract 33 from both sides of the equation. So then I have negative 20x on the left is equal to, those cancel out to be 0, so we've done this correctly. Negative 33 minus 7, very carefully, is negative 40. Now remember our goal. We're trying to solve for x piece by piece, so we're going to divide both sides by negative 20. So then we get x is equal to 2. Positive 2, because a negative divided by a negative is indeed positive. Okay, we get x is equal to 2. Now we need to find our other variable. So let's go plug that in into one of our original equations. I'm going to use this because that would be solving for y directly. But we have to plug that 2 in wherever there's an x. So right there. So we know y is going to be equal to 6 times x, but x is 2, so 6 times 2, and then minus 11. So we know y is equal to 6 times 2 is 12 minus 11. So we know y is equal to 12 minus 11 is 1. We found x, we found y. We write our final answer as x comma y points. So x is 2 and y is 1. So our final answer will be 2 comma 1. All right, and I'm going to do number 10, and it will be my last one. So I would do number 10 with me, and then you'll have the rest of the time to work. This is number 10 from the worksheet. So we have negative 5x plus y on top is equal to negative 3. And on bottom, we have 3x minus 8y is equal to 24. I'm going to solve using substitution. Now remember, you have to isolate a variable, get it all by itself, and then we can substitute. Well, looking here, this top equation we can get y all by itself pretty easily. Now, to get y by itself, I'm going to have to add 5x to both sides of the equation. All right. So then over here, that's going to add up to be 0, which is what we want. So over here on the left, we now have y is equal to then 5x minus 3. Remember, those aren't like terms. You can't combine them. So we'll write it as 5x minus 3. All right, so we've now isolated y. We've isolated our variable without getting fractions. So now we'll go ahead and substitute that into the other equation wherever there is a y. So we're going to be making the substitution right there. So we're going to have 3x minus 8 times y, but y is 5x minus 3. Make sure when you're making your substitutions, you put parentheses. We're substituting it in right there, which is equal to 24. And now we can simplify and solve. So we have 3 x's. Now once again, we're multiplying -8 to all that stuff. So -8 times 5x is -40x. -8 times -3 is +24, which is equal to 24. Now, our goal is to get x all by itself. Well, first of all, let's combine our like terms. 3x's minus 40x's is -37x's. So we have -37x's plus 24 is equal to 24. Now solving for x piece by piece, we'll subtract 24 from both sides of the equation, leaving me with -37x is equal to 0. So then we'll divide both sides by -37. So x is equal to 0 divided by -37 is 0. So we have x is equal to 0. All right, we're almost finished. We'll go and substitute that x value back into one of our original equations to solve for y. So we're going to have y is equal to 5 times x, but x is 0, minus 3. So we're going to have y is equal to 5 times 0 is 0 minus 3. So 0 minus 3 is minus 3, -3. So we just found our y value to be -3. Our final answer we write as x comma y. So we're going to have 0 comma -3. And this would be our final answer. All right, that's the end of the video. So now you'll do the worksheet. Thank you for watching.